Day 71. Today we're learning about integral rules. There are some rules that are very helpful with integrals that are going to make things easier for us. So it's important to know these rules in terms of making integration easier for us when we come across them. And the rules themselves are specifically tested upon too. We'll take a look at what an example of that could look like as well. So let's start with the first rule. It's a very simple one. What if we performed a definite integral from a to a? Now, usually we talk about the integral from a to b, right? But what if we went from a number to itself, like the integral from 3 to 3, or the integral from -5 to -5? How much area would there be under the curve if we're not covering any distance from our lower limit to our upper limit? Well, there might be a height, but there's not going to be any width. So that area is going to be 0. Very simple rule, but definitely comes in handy on some tougher problems. We'll see later on. So kind of an example of that. If we see this problem, we do not have to perform an antiderivative, and then, right? I don't have to be like, okay, so we got 6/4 x to the 4th minus 4/3 x cubed plus 5x, and I got to plug in 3, and then I got to plug in 3, right? When I plug in 3 to evaluate in this, I'm going to get the same answer, so when I subtract them, I'm always going to get 0, right? We can just skip to the end and say this equals 0. So, again, an easy rule, but very effective. Rule 2. I always state, and I want you guys to get in the habit of this, I always state integrals, I always say the bottom number to the top number, right? And I usually talk about the integral from a to b. But what if those two numbers are flipped? What if I have the integral from b to a of f of x dx? Well, if we have that, anytime we have the numbers in a way that it would be easier if they were flipped, we can always do that. We just have to make a small adjustment for it, right? If you think about what this would be in the fundamental theorem of calculus, it'd be capital F of A minus capital F of B, when we're used to capital F of B minus capital F of A. Well, if we subtract two numbers in a different order, right, let's say we do 5 minus 3, well, we get 2. If we switch the order, 3 minus 5, we get -2. Right, so we always end up with the opposite sign. So anytime we have an integral, and it's not going the order that we want it to go in, we can just flip the order. And all we have to do is put that opposite sign out front. For example, if I told you that the integral from 5 to 3 of f of x dx equals 10, what would be the integral from 3 to 5 of f of x dx? Well, it would just be the same answer, but the opposite sign, so it's going to flip to -10. Okay. Third, if we have the integral from a to b of a constant k times a function f of x dx, we can simply pull that constant out in front. I call it throwing it out in front. Let's throw that k out front. That's the same as k times the integral from a to b of f of x dx. Let me show you an example here. Okay, so let's say we have this problem. We have the integral from 3 to 15 of 8 over x dx. Well, we can make this easier for us, right? I don't really know what the antiderivative of 8 over x is going to be, but I know that 1 over x is the natural log of absolute value of x. That's its antiderivative, right? So this is the same as saying I can just take that 8 and throw it out front. Now when I evaluate this thing, I'm just going to keep the 8 out front, and I'm going to keep writing it over and over again so I don't forget about it. And again, I'm going to keep writing that 8 out front. And I can keep writing that 8 out in front, and my answer is just 8 ln 5. So, or if I wanted to integrate 6 cosine x, I'm just going to throw the 6 out front and do the integral of cosine. I know that's sine, so my answer is 8 sine x. Plus c if it's an indefinite, then I'd plug in the numbers if it was definite. Okay, that's rule number 3. Rule number 4, we've already looked at this rule, but it's worth putting in your notes again. We can always split integrals. So if we have the integral from a to b of a function f of x, and whether we're adding or subtracting g of x, I can split this into 2 integrals. Right? If it was f of x plus g of x, I can split this into the integral from a to b of f of x plus the integral from a to b of g of x. If it was minus, I could do minus. So just to save space, I'm going to write this as integral from a to b of f of x dx plus or minus the integral from a to b of g of x dx. Now, sometimes splitting an integral doesn't make it any easier. It actually makes it to be more work. But we're definitely going to want to split integrals when we get to u substitution later. Okay? And it's always a strategy if we're stuck and we can't solve something, it's a strategy we can use. All right, the 5th rule is a big one. And I think that's the final rule for this video. Okay, so if I have an integral that goes from a to b, and an integral that picks up where that one left off at b and goes to c of the same function f of x, that equals the integral from a to c of f of x. Right, we can just think of it as adding those 2 areas together. Let me show you an example here. Let's say that I know the integral from 3 to 6 of f of x dx equals 10. And I know that the integral from 6 to 8 of f of x dx equals 4. Those are 2 things that I know. What would be the integral from 3 to 8 of f of x dx? Well, since 3 to 6 is 10 and 6 to 8 is 4, this is going to equal the sum of those two integrals. So we're going to get an answer of 14. Now that's kind of an easy example on looking at it. What I want you to think about with this is we're going to call this, right, A to B is a small region, B to C is a small region. Together they add to the bigger region. I like to call this part plus part equals whole. Part plus part equals whole. I want you to think about it like that. That was an easy example because I gave you the two parts. You just had to add them together to get the whole. But sometimes they'll give you a part and a whole, and you have to find the missing part. Okay? So let me show you. I'm going to do two examples here just so you can see it. F of x dx equals so here I gave you the integral from 1 to 7 of f of x dx, I told you is 8. And I told you that the integral from 4 to 7 of f of x dx is negative 3. Well, if you notice, 1 to 7 spans, you know, that 4 to 7 is included in the 1 to 7, right? 4 to 7 is a part of the 1 to 7 whole. So if I wrote a question about this, I'm not going to be adding 8 and negative 3, okay? The question that will be asked is, what? Well, what would be the missing part here? I've got 4 to 7 and I've got 1 to 7. The missing part would be the integral. What they're going to ask is, what's the integral from 1, oops, not 3. What they're going to ask is, what's the integral from 1 to 4? Right? 1 to 4 is a part, 4 to 7 is a part, 1 to 7 is the whole. Right? So what would be the integral of this? So I don't want you to just always add the numbers together, right? What I want you to think about is this. What I want you to write out is identify the two parts, right? This is my question. What is the integral from 1 to 4 of f of x dx? Well, let's write it out as part plus part equals whole. Okay, the first part is the integral from 1 to 4 of f of x dx. The second part is the integral from 4 to 7 of f of x dx. And the whole is the integral from 1 to 7 of f of x dx. Okay? Now it's written in a nice way that we know. And what I do is I'm just going to add in the numbers for the things that I know numbers for, and I'm going to put in an x for the thing I don't. Right? This 1 to 4 f of x dx, that is unknown. That's what I'm trying to solve for. So I'm going to call that x. The integral from 4 to 7, that's known. The integral from 4 to 7 is negative 3. And that has to equal 1 to 7, which is the whole, which is also known. The integral from 1 to 7, we know from up here, is 8. So I've got x minus 3 equals 8. Now I just solve the equation. I add 3 over and I get x equals 11. Therefore, the integral from 1 to 4 of f of x dx must equal 11. These kind of problems can sometimes make your brain hurt, and that's okay. We'll figure it out. What I'm going to do is I'm going to state some knowns. Oftentimes in the multiple choice section of the test, they'll state some known things for you, and what you have to, then they'll ask a question. And usually the one question combines lots of different pieces together. Right? It's going to test you over like 3 or 4 rules all at the same time. So Watch this example. I'm going to give you one example of this, of what it looks like, and we'll look at a lot of them in class on Monday. So here's what's known. The integral from 0 to 5 of f of x dx equals 10. The integral from 2 to 5 of f of x dx equals negative 3. And the integral from 0 to 2 of g of x dx equals 5. Okay, so that's our given information. We know the integral from 0 to 5 of f, we know the integral from 2 to 5 of f, and we know the integral from 0 to 2 of g, right? So here's the question. Whoa. Okay, so there's a lot going on here. When I look at this, I see a couple of things. Number one, the integral that I was asked appears to go backwards to me, 2 to 0, right? I see both f of x and g of x in there, separated by a subtraction sign. And I see a 3 in front of the f of x and a 5 in front of the g of x. Those are all problems that I'm going to slowly solve here. Okay? So if I was posed this question, here would be my moves. Now, as you get better at this, you might do a lot of these moves all at the same time. Just be very careful when you do that. Okay? I'm going to show you step by step what I would do, and I'll let you make the decision on how many steps you want to combine. The first thing I'm going to do here is I'm going to split the integral. Right? I'm going to split this. I'm not going to change anything else. I'm simply going to split the integral, making sure that I maintain everything else the same. Oftentimes, if you try and do too many things at once, you'll lose track of a sign or something like that, and the test loves to do that to you. Okay, then I'm going to say, okay, I have a constant times f of x, I have a constant times g of x. I'm going to throw that out front. So I'm going to change this into 3 integral. I'm going to keep everything else the same. 2 to 0 of f of x dx minus 5 integral 2 to 0 of g of x dx. Okay. Once I've split and thrown the constants out front, I'm going to address the problem that I'm going from 2 to 0 when I really want to go from 0 to 2. So I'm going to flip both of those. And when I do that, I have to throw an opposite sign out in front, right? So that 3 is going to change to a negative 3. That minus 5 is going to change to a plus 5 as I change both limits of integration here. Oops. So as I do that, this 3 here became a minus 3. This minus 5 became a plus 5. Okay. So, let me just get those out of there. Okay, now one of these is going to be really easy to solve, right? this integral 0 to 2 of g of x dx, that was just explicitly given to me. I know the integral from 0, right? Uh-oh. Stop. Ah. Okay, so I know the integral from 0 to 2 of g of x is 5. Okay, but what I don't know is the integral from 0 to 2 of f. But I can figure it out because I have a whole here and I have a part here. And the missing part is 0 to 2. Right? They're never going to give you a problem you can't solve. You're always going to have the ability to solve it. So what I would do right now is I'm just going to figure out what the integral from 0 to 2 of f will be. Well, I know that the integral from 0 to 2 of f plus the integral from 2 to 5 of f must equal the integral from 0 to 5 of f of x dx. Right? This right here, 0 to 2 is unknown, so I'm going to call it x plus the integral from 2 to 5, that's -3, and that equals the integral from 0 to 5, which I know is 10. What I get here is I get x equals 13. So what I know, what I can add to my list of known, is the integral from 0 to 2 of f of x is dx equals 13. So 0 to 2 of f is 13, 0 to 2 of g, I didn't have to do that kind of analysis here because it was just given to me, that was a freebie, is 5. So now I can go back in here, I can replace this 0 to 2 of f of x, I'm going to replace that with a 13, that's what I calculated it to be, plus 5 times the integral from 0 to 2 of g was 5. So I get -39 plus 25. Need to figure out what that is. That equals -14. That is my answer to the question. So, well, they love to make you use a lot of rules all at the same time. It can kind of hurt your brain a little bit looking at it. But just know it's always solvable. Just go step by step and you can get it. That's it for today. Have a good long break. Geez, another break. 2 chains, bye.